Hello friends, welcome to our website automationcommunity.com. We are going to see very interesting example which is sequential operation of production line. Friends, in the industry there is a production line and there is proper sequence to turn on the process and turn off the process. First of all, let me explain you what is our user process. This is the feeding conveyor which feeds different raw material in powder form to our grinding machine. This is our grinding machine which mixes and grinds our raw material, and this is the output conveyor which transfers the grinded raw material to another process. Now assume if I turn on this machine before turning on the grinder, then what will happen? It will start transferring material to my grinder. Now if I will on my grinder, it will not start and trip because of overload. Similarly, if I turn on these two machines before turning on this conveyor, so what will happen? It will start depositing material over here. And now if I will start this conveyor, it will not start because it is jammed over here and it will also get tripped due to overload. So what is the proper sequence to turn on this production line? So the conclusion is, first of all we have to turn on the last machine in the production line and then turn on the respective machines in reverse order. That is, first I will turn on this output conveyor, then after some time I will turn on my this grinder, and after some time I will turn on this feeding conveyor. So now my machines will not get tripped and it will work smoothly. Similarly, there is a proper sequence to turn off this production line. And what is it? So for example, if I turn off this machine before turning off these two machines, then what will happen? It will continuously start depositing material over here. Now this material is not transferring to somewhere else because this conveyor is already stopped. So material will start filling in grinder itself and eventually the grinder will trip because of overload. Similarly, if I turn off these two machines before turning off this machine, so what will happen? It will keep transferring raw material to grinder. So on the next day, when I will start this grinder, there will be already some material in it, and so it will not start and get tripped due to overload. So let us see exactly what will be our user definition. When the user press this start button, first of all, my output conveyor Y2 should be start. After the delay of 5 seconds, my grinder must be start, and after the 5 seconds from starting of grinder, my feeding conveyor will start. Similarly, when the user will stop process from this stop button, first of all my feeding conveyor will become off. After 5 seconds of delay from that time, my grinder will be off, and after the 5 seconds from turning off of grinder, my output conveyor should be stopped. So let us understand what will be our wiring diagram. Simply, we have only two inputs, start button and stop button. So first of all, I will connect the ground terminal of my SMPS to the common or source sink of my digital inputs, and I will connect the 24-volt supply to the each terminal of my buttons, and the another terminal of start button I will connect it to X0 position, and the another terminal of stop button I will connect it to X1 position. Now in the same module, at the digital outputs we will connect our outputs. This is the same PLC, just for sake of simplicity I have drawn output on the different page. Now again we will connect ground terminal of our SMPS to common of digital outputs, and as you know, we don't directly on off the motors through PLC. we on off the motors through relay, and relay will energize the respective contactor of motor, and so the motor will start and stop. Simply one terminal of each relay I will connect it to 24-volt supply, and another terminal of relay 1 I will connect it to Y0, which is my feeding motor. Remember these things. Another terminal of relay 2 I will connect to Y1, here Y1, which is my grinding motor, and another terminal of relay 3 I will connect it to Y2, which is my output conveyor motor. If you are feeling any confusion, refer to this image. Here I have written that my Y0 is feeding conveyor, my Y1 is grinding motor, and my Y2 is output conveyor. My X0 is start button and X1 is stop button. Similarly, I have used two timers, one for turning on the process and one for turning off the process. So here I have used two displays to show that particular time instance. We will see what is the logic required to create this project. First of all, if the user press this start button, it should set my Y2, which is my output conveyor. My output conveyor should start instantaneously as the start button is pressed, and it should also start one timer T0. So for this I have used two instructions. First is the set command and another is the timer instruction. Now timer will start counting the time. When timer reaches to the value of 5 seconds, my another output, which is the grinding motor, it should set. Set means it will just turn on the Y1 and keep it latch. So for this I have used compare instruction and set instruction. Now when finally my timer complete its timing of 10 seconds, it will set my output Y0, which is my feeding conveyor. Now friends, what I wanted, my grinder should start after 5 seconds of starting of Y2, and my Y0 should start after 5 seconds from starting of Y1. So I have used one timer to turn on two outputs, Y1 and Y0. If the user press this stop button, instantaneously my feeding conveyor should be resetted or become off. It will, and it should also start my timer T1. So for this I have used reset command and again timer command. Now as here we have used 10 seconds for T0 timer. Similarly here will we use 10 seconds for T1 timer. So it will start its timing. When the timing will reach to the 5 seconds, it will reset my Y1, which is my grinder. So again for this I have used compare and reset instruction, and when my T1 timer reaches to the 10 seconds, so what it should do, it will also reset my output conveyor Y2. So for this simple I have used reset command. So friends, let us start our programming. So friends, I will start my ISP of software from here. First of all, I will click on new button. Here we will give name to our project. Just press OK button. As usual, first of all, we will write device command list from here, double click on it, and this dialog box will open. So first of all, X0 is our start button. So I will click on it and write start button. Okay. X1 is stop button. As we only have two inputs, so now I will write outputs. Y0 is my feeding conveyor. Y1 is our grinder, Y2 is our output conveyor. What else we have used? We have used timers. T0 is my timer for turning on the process. So here I will write turn on timer, and T1 is my timer to turn off the process. So here I will write turn off timer. So now I will close this box from here. We will click on program and right click on it. Click on new file. So here we will give name to our program. Here you cannot use space. Just click OK over here. Here I will write network comment. So first of all, what we want to do, start Y2 and start timer T0. Press enter. So first of all, I have to select one contact from here. Bring your cursor to this red portion and click over it. So the contact is created. Let us give name. This is my X0 button. Press enter. Select over here. Now first of all, we want to start our output Y2. So for that, I have to select a coil from here. Bring your cursor to this portion and select pointer and give name. This is my Y2. Click here. You can see this is output conveyor. Now in parallel to this, also what I want to do, I want to start my timer T0. So for that, we will go to functions block. From here, select all types. Now here you write TMR because this is the mnemonics for timer. You have to remember it. Click on the insert button and you can see our timer block is created in parallel to our output Y2. So first of all, in the S1 here, what we will write? We will write the number of timer we are using. So we are using T0. Now here we will write up to what time it should count. So we want 10 seconds. But for that, here we need to write 100 because this is the 100 millisecond timer. So if I will write 100 over here, it will be taken as 10 seconds. Now we want new network, so click over here. Now what we want to do, compare the value of timer, and when it reaches to the 5 seconds, my output Y1 should start. So here I will just write compare and start Y1. Press enter. Before we move ahead, here I forget to set this output. This is the normal on, but we want to set. So for that, click over it, press the space button, and from here I will select set. Now even if my X0 button is off, my Y2 will keep on because generally in the industries we just press the button and release it. So this will keep my output latch. Similarly here, what we want to do, we want to compare our timer, but when the comparison should occur, if the system is on. So first of all, I will select contact from here, bring my cursor to here, and here I will write X0. Click over here. If my system is on, then only this comparison will occur. Now here I want one comparison block. So for that, go on functions. Here select comparison instruction and what we want greater than equal to and click enter. click insert. So our block is created. Here first of all we will write our comparator. So here it is T0. We want to compare T0 with what? With 5 seconds. So here I will write 50 because as you can see for 10 seconds I have used 100. So when the T0 will become 50, it will treated as 5 seconds. So when the value of timer is greater than equal to 5 seconds, what should happen? My output Y1 should be on. So it is same like this. I have to select coil from here, bring your cursor to here, select pointer. Here I will write Y1. Then we want to set this. So for that again click on it, press the space button and select set from here. So now it will set my grinder. Again insert new network from here. Now what we want Y0, which is nothing but our feeding conveyor. So for that select a contact from here, bring your cursor to this red portion and click OK. Now when my feeding conveyor should start? When it is 10 seconds from the starting of my Y2. So when 10 seconds will be completed when the T0 is set. So here I will write T0. Click over here. Again we will select one coil and we will give its name Y0. So when the 10 seconds time is completed, this T0 bit will be on and it will make our Y0 on. So again click over it, click the space button and select set. So this was code to turn on our process. Now we want to turn off our process. So first of all we will insert a network from here. We will select one contact from here. Bring your cursor to here and here we will name it X1. So when the X1 is pressed, what should happen? First of all, my feeding conveyor should be resetted. So for that, I will select coil from here, bring your cursor to the red portion, click on pointer and name it Y0. First of all, my feeding conveyor should be off. So here I have to select a reset. So select it, press the space button and select reset from here. As soon as this button is pressed, my output should become off. And also it should start one timer which will count time to turn off the process. So for that I will go to functions block, select the all types. Here I will write time, TMR timer, insert it. Again here this time I am going to use timer T1 because we have already used T0. So now I will use T1 and here again I will write 100 because we want 5 seconds delay in turn off grinder and 5 seconds delay to turn off, another 5 seconds delay to turn off output conveyor Y2. So total time delay is 10 seconds. So for that I will write a network comment here Y0 and start timer T1. Press enter. Again we will click on new network from here. Now what we want to do, compare the value of timer when it reaches to the 5 seconds, my grinder should off. So here I will write compare T1 and off Y1 which is my grinder. So press enter. Again I will select one contact from here which is my stop button. So go on contacts, bring your cursor to this portion, name it X1. When my stop button is pressed, this condition should work. So again I will select one compare instruction. From the functions block, click on compare. Again we will select the same greater than equal to sign. Here I will write T1 and again here I will write 50. So when the value of T1 reaches to the 5 seconds, it should off my, select over here, it should off my output Y1. So for that I will select coil, bring your cursor to here, select pointer and name it Y1. Now this time we want to reset this, so select it, click space button and select reset button. So after 5 seconds from turning off the Y0, my Y1 will be off. Similarly, select new network from here. This network will stop our output conveyor. So stop Y2, enter. So when my timing is completed, it should off my Y2. So simple, I will select contact, bring your cursor to here and here I will write T0. Click over here, select a coil, bring your cursor to here, select pointer and name it Y2. So when the timer will complete its timing, reach 10 seconds, sorry, here I have to write T1. So my T1 bit will on and it will reset my output Y2. So here I have to select reset. So this was about our turning off process. So friends, here we have completed ladder diagram programming. Its HMI designing and simulation we will do in part 2 of this video. So if you want to learn more examples like this, show your interest by liking and subscribing our YouTube channel Automation Community. Meet you in the next video.